Problem 102, Quantum Mechanics. The question is, using the trial function psi of x equal to a within bracket a square minus x square minus a less than x less than a, 0 otherwise, the ground state energy of a one-dimensional harmonic oscillator is. Here, we have to find out the ground state energy of a one-dimensional harmonic oscillator using the trial function given. The given function is psi of x equal to a square minus x square. First, let us find out the value of the capital A under normalization condition. That is integral minus a to a psi star psi dx equal to 1. This implies integral minus a to a square. Now a square minus x square whole square dx is equal to 1. Now we can write it as a square into 2 times integral 0 to a square minus x square whole square dx is equal to 1. That is 2a square integral 0 to a. Let us expand the terms. A raised to 4 plus x raised to 4 minus 2a square x square dx is equal to 1. This implies that 2a square. Now after integration we have a raised to 4x plus x raised to 5 by 5 minus 2a square x cube by 3 within the limit from 0 to a is equal to 1. That is 2a square into a raised to 5 plus a raised to 5 by 5 minus 2a raised to 5 by 3 is equal to 1. This implies that 2a square into a raised to 5 by 15 is equal to 1. From this expression, the normalization constant a is equal to root of 15 by 16 a raised to 5. Therefore, our wave function psi of x becomes root of 15 by 16 a raised to 5 a square minus x square. This is the trial function. Now using this trial wave function, we have to find out the ground state energy. First, let us calculate the expectation value of the potential energy. We have the formula integral minus a to a psi star half m omega square x square psi dx is equal to expectation value of V. Now this is equal to integral minus a to a psi star half m omega square x square psi dx, because for harmonic oscillator V is equal to half m omega square x square. Therefore, the expectation value of potential energy is integral minus a to a 15 by 16 a raised to 5 a square minus x square whole square half m omega square x square dx. This is equal to 15 by 16 a raised to 5 half m omega square 2 times integral 0 to a x square a square minus x square whole square dx. This is equal to 15 m omega square by 16 a raised to 5 integral 0 to a raised to 4 x square plus x raised to 6 minus 2a square x raised to 4 dx. This is equal to 15 m omega square by 16 a raised to 5 integral 0 to a. Now let us integrate the term a raised to 4 x cube by 3 plus x raised to 7 by 7 minus 2a square x raised to 5 by 5 within the limit from 0 to a. This is equal to 15 m omega square by 16 a raised to 5 a raised to 7 by 3 plus a raised to 7 by 7 minus 2 a raised to 7 by 5 This is equal to 15 m omega square by 16 a raised to 5. (35 a raised to 7 plus 15 a raised to 7 minus 42 a raised to 7 divided by 105, and this is equal to 15 m omega square by 16 a raised to 5, 8 a raised to 7 by 105. This is equal to m omega square a square divided by 14. That is, the expectation value of potential energy is m omega square a square divided by 14. Now let us find out the expectation value of kinetic energy. Expectation value of kinetic energy is given by h bar square by 2m integral minus a to a d psi by dx whole square dx. We have psi of x is equal to root of 15 by 16 a raised to 5 a square minus x square. Now what is d psi by dx? D psi by dx is equal to root of 15 by 16 a raised to 5 minus 2x. Now the expectation value of kinetic energy is h bar square by 2m integral minus a to a root of 15 by 16 a raised to 5 square then 4x square dx. This is equal to h bar square by 2m 15 by 16 a raised to 5 into 4, that is 15 by 4 a raised to 5. Now 2 times integral 0 to a x square dx. This is equal to 15 h bar square by 4m a raised to 5 into a cube by 3. Therefore, the expectation value of kinetic energy is 5 h bar square by 4m a square. Now we have the expectation value of kinetic energy, the expectation value of potential energy. Now we can find out the expectation value of Hamiltonian, and from that we can calculate the unknown parameter or the adjustable parameter a in the wave function psi of x. First let us write the expectation value of Hamiltonian is equal to expectation value of kinetic energy plus expectation value of potential energy. This is equal to 5 h bar square by 4m a square plus m omega square a square by 14. To find the parameter a in psi of x, take dou h by dou a equal to 0, and from that expression we can find out the value of a. Dou h by dou a equal to 0 implies 5 h bar square by 4m then minus 2 by a cube plus m omega square by 14 into 2a is equal to 0. This implies that 5 h bar square by 2m a cube equal to m omega square a by 7, or a raised to 4 is equal to 35 by 2 h bar square by m square omega square. Therefore, the unknown parameter a is given by 35 by 2 h bar square divided by m square omega square whole raised to 1 by 4. This is the value of the adjustable parameter in the wave function. Now let us find out the ground state energy which is asked in the question. We have expectation value of h is equal to expectation value of t plus expectation value of v. This is equal to 5 h bar square by 4m a square plus m omega square a square by 14. We have evaluated the value of a. Substitute the value of a. We will get expectation value of h is equal to 5 h bar square by 4m root of 2 by 35 m omega by h bar plus m omega square by 14 then root of 35 by 2 h bar by m omega. Now after simplification we will get it as h bar omega by 2 root of 50 by 140 plus h bar omega by 2 root of 35 by 98. Now this is nothing but h bar omega by 2 root of 5 by 14 plus h bar omega by 2 root of 5 by 14, and this is nothing but root of 5 by 14 h bar omega. Hence, we can say that the ground state energy of the one-dimensional harmonic oscillator is root of 5 by 14 h bar omega. Hence, we can say option B is the correct option.